Hey everyone, hope you're doing well. Here's a video to go along with today's lesson. And so what we did today was we continued working on our BrickOut game, and we got it so that we have basic functionality by the end of it. So we were able to have collisions between the ball and the other bricks and the paddle, and have it so that the bricks disappeared after they got hit. So that is going to be what we do in this video. But before we get to that, we need to kind of finish off a little bit with what we stopped off last time. And so last time when we were working, we got our paddle to move by pushing the left and the right buttons on the keyboard. For those of you that were following along in class but didn't watch the last video, we need to add this line here in order to get it so that our paddle moves correctly. So that was the thing that we were missing in class, but it's in the previous video. And the reason why we need to do that was because we draw based off of where the rectangle is, that collision box. And so we need to update the location of that collision box every time that we move the paddle. And so that's the reason why it wasn't working before. So let's quickly run this thing, show where we are currently in our game. So ball moves, bounces off the edge nicely, and we can move the paddle back and forth, but we got a problem. The paddle can go off the screen. That should not be allowed. We need it so that the paddle will stay on the screen. So that's what we're going to do first, and then we're going to look at getting the collisions to work. So let's close that, and this is going to work very much like how we did it with the ball. So we are going to, in our constructor function here, we're going to set what the max left and the max right our paddle is going to be allowed to go. So self.max left. Remember that the position of our paddle is measured from its top left corner, not the center. And so the maximum left would be is 0 when that top left corner is at 0, which is as far left as you can go, without going off the screen, of course. So max left is going to be 0, but max right is not going to be 120 or 1200, which is the length of our screen. And that's once again because our measuring point, our X position, is the top left-hand corner of that box. We need to stop when the top right-hand corner, or the right-hand side, touches. So we need to stop 120 pixels before that point, because the length of the paddle is 120. So we're going to do self.window.getWidth, same thing as we did with the ball. So same idea here, but we're going to be subtracting the length of the paddle. So scroll back down, and where are we? Right here. Minus self.length. There we go. So that will be the most right this thing can go. Now that we've established what the boundaries for our paddle are, we need to go down in our update function, and we need to enforce those. So after we've done all of our updating and we moved it, what we're going to do is check whether or not the X position is outside of that range, and if it is, then we'll move it. So if it's gone too far left, then we'll make it as far left as allowed to go, and if it goes too far right, we'll make it as right as far as it can go. So it's going to look like this. So if self.x.x is less than self.maxLeft, then we will set self.x to maxLeft. And elif, so we may as well combine these two conditions, make it run a little bit faster. So if self.x is greater than self.maxRight, then self.x will equal self.maxRight. So if it's gone too far right, then we will just reset it so it's as right as it's allowed to go. And that should be everything that we need to do. So if we run this thing again, it should no longer be possible for us to move the paddle off the screen. Oh. There's an error. Oh, it's supposed to be uppercase. Whoopsie. So back up here, self.window, W should be capitalized, like that. Try it again. There we go. And can I go to the left? And it stops. Can't go any farther left. Go to the right. It stops. Can't go any farther right. Perfect. So our paddle is now forced to stay on the screen. We can't make it go so far that it just disappears. Great. Now we can start doing our collisions. But before we get into the collision code and how is it going to be bouncing off of the different things, we're going to need to give our ball a collision box. So up in our reset ball, this would be a good place to define our collision box for a ball. And so I'm going to do self.rect. So calling all of the rectangles exactly the same thing. And it makes it a whole lot easier when you're dealing with different objects, but they all refer to the similar properties the same way. That means you can refer to all the objects in the same way without actually having to use something unique for each individual object. So self.rect is going to be a new rectangle, but we need to identify what is going to be this rectangle. Our ball doesn't measure things from the top right hand corner because balls don't have top right hand corners, or left hand corners, sorry. It measures it from the center of the ball. So what we're going to need to do is draw a square around that ball, and that will be our collision box. So I'm just going to quickly show you graphically what we're thinking about here. So we're going to have our ball. It's going to look something like this. And the center of that ball is right there. So that is, whoops. Anyways, right about there. That is where we are measuring our ball, or the location of our ball. Actually, I got a stylus here. Let's use that. So that's our ball, center of our ball right there. We want to draw a box around it. So this is going to be our box that we're drawing around our ball. And its position is not the center of the ball. It is the top left-hand corner right there. So this is the position of the ball, our XY coordinates, but we need to give the XY coordinates of that point right there. So if this is X, then up here is going to be X minus the radius, because we've gone up by one radius of that circle. And if this is, I suppose that should be Y. Whatever. So pretend that's X and that's Y, flip them around. So if that's our Y coordinate, should be X. Then this is going to be Y minus R. So that is how we're going to get our coordinates, and the size of this is going to be the diameter of our circle. So that's going to be what we're doing next. So the position of our rectangle is going to be self.x minus self.radius. The y position is self.y minus self.radius. And the length and the width is going to be diameter, or just the radius times 2. So self.radius times 2, and self.radius times 2. There we go. So that is our collision box for our ball. And we need to update the position of our box in our update function as well. So we're going to do it exactly the same way. At the very end, we're going to update our collision box. So self.rectangle, our collision box. I'm going to update it. And then we need to give all this stuff that's in brackets right there. And it's going to be exactly the same right there. just update it using all the new values. These are going to stay the same, but actually I suppose the y will stay the same as well. Oh, we're missing a minus sign right there. Minus. There we go. So that is going to be our collision box for our ball, and how we detect whether or not it's run into anything. So we're almost ready to... Actually, I suppose we could go and start our bouncing now. So, in our main game class, we are going to make a new function that I'm just going to call bounce, which is going to be what we call whenever the ball bounces off of something, and it will handle redirecting the ball in the correct direction. So def bounce, it needs to have self as an argument, of course, a parameter, because it is a class function, and it always needs to have self as the first parameter. It's also going to have, I'm just going to call it the object, which is going to be the thing that is bouncing off of. It could be the paddle, it could be one of the bricks. Doesn't matter, because we're going to handle them both the same way. Paddle and the bricks are basically just rectangles. So as long as we have it so it bounces off rectangles, it should work for both. So, to do this, we need to identify what are the cases of our ball bouncing off of our rectangle. So let's go back to our little whiteboard, and let's identify what the different cases are and what we're going to be doing for each one of those cases. So, right here. So let's make our rectangle. This is going to be the thing that we're bouncing off of. I want that to be in black. There we go. So this is our rectangle we're bouncing off of. Case 1 is going to be when we are in this region here. So above or below our brick, basically. So either we're coming in, bouncing off there, and then bouncing off, or we're coming in like this, and then bouncing off like that. Either way, we're going to be reflecting the velocity of the ball over that line. So those of you that have done perhaps any Physics 30, this looks a whole lot like a reflection in optics, where the incident angle is equal to the reflection angle. And so our ball comes in like this and leaves like that. Comes in like this, leaves like that. That's our first case. And if this is the case that's happening, then we are just going to invert the y velocity. So if it's coming down, it's going to go up. If it's coming up, it's going to go down. But the x velocity is going to stay the same. That's not going to get changed at all. And so remember, this is our point of the location of our block, or whatever it is that we're bouncing off of, is always from the top left corner. So we need to know whether or not the center of the ball is somewhere between here and here, which is going to be the x position of our block plus its length. Because that's the x position here, this is going to be x position plus the length of the block. So that's going to be what we do first. Let's go back to our code. And so we need to write that condition is the x position of our ball between those two values. So if self.ball, actually we're going to do object.x less than or equal to self.ball.x less than or equal to object.x plus object.length. I think that's how I was dealing with our two things. Yeah, length and length. Oh, one other thing is something I forgot to erase before I made this video was this right here. So this was not in our code previously. This we added. We need to know what the x and the y position of each brick is. So we're going to do self x and self y, and just assign these values to them. Because when we're doing our bounce, right here, we need to know what the x position of that object is. So, if our ball is somewhere between those 2 points, that means we're in the first case, and so we're just going to reflect the ball's y velocity. So self.ball.val y multiplied by -1. So that will reflect it in the y direction. Next case is going to be case 2, and case 2 looks very much like case 1. So let's go back and take a look. And case 2 is going to be when we are below that line but above this line. So our ball is going to be coming in like this, and it's going to bounce off like that. Or a ball is coming in like this, and it bounces off like that. So reflecting over this line or that line, which means that we're just going to invert or multiply the x velocity by -1. So it goes the opposite direction, but the y velocity stays the same. And once again, ball goes in, ball comes out. Ball comes in, ball goes out. So that is our second scenario of our ball hitting one of these bricks or a paddle. Does it come in from the side? If it does, well, the if statement for that is going to look very much the same. Oops, opening up the wrong one. There we go. So if object.y is less than or equal to self.ball.y less than or equal to object.y plus object.width, then self.ball.the velocity of the x should be multiplied by -1. So that's our second scenario. Second case that we need to consider. We have one more case that we need to consider, and that is what if the ball comes in and hits one of the corners. And so this one is going to be a little bit more complicated, and to be completely honest, it's not going to be completely accurate, but it will work pretty well for what we want to do. So, what the scenario is it's going to hit, so let me actually draw here. This is case 1, this is case 2, and then hitting a corner is case 3. And so it will hit like that, and it's going to come out like that, and it's going to get reflected over this 45-degree line. So that is a reflection. All of these are basically reflections, and that's going to be how we do it. It comes in, and it's going to bounce off like that. Let me draw this a little bit more, because I want to go into detail, a little bit of detail of how we're going to actually calculate this thing and make it a little bit easier on ourselves. If we wanted to do this properly, we would need to use linear algebra, which you'll learn about in first year university. But I don't want to do first year university math for a grade 11 program. So we're going to make it a little bit easier on ourselves. So this is a corner. This is going to be the line we reflect over. And I'm going to say, okay, our red is going to be the ball coming in. Green is going to be our ball coming out. Like that. And what I want to do is I want to break these down into their x and y components. Because I want to show you something that's going to be true whenever you reflect something over a 45-degree line. So what I'm going to do is I'm going to take, say, blue is going to be this line. And this line. And what's more, I'm going to say purple is this line and this line. And I didn't do that for any arbitrary reason. There's a good reason why I did that. So this is, the red line is our ball coming in. And the key thing about when you reflect over a 45-degree line is that your initial x magnitude of your velocity will equal your final y velocity in magnitude. Not in sign, but in magnitude. These two parts are going to be equal length. Likewise, the initial y velocity coming in is going to be equal in magnitude to the final x velocity coming out. So the magnitude of our two velocities are going to get swapped, and then we just need to handle the signs. And in almost every case, the sign, the direction that's going to be moving, is going to be in the totally opposite direction that it was coming in. So if we're coming in with a positive y value, we're going to leave with a negative y velocity. If we're coming in with a negative x velocity, we're going to be leaving with a positive x velocity. So it's reflecting off in some way. This doesn't hold for every case. It only really comes in as long as we come in with a reflection angle of 45 degrees or less. The special case that this doesn't work well is I'm going to do red and green again. So what if we came in like this? In that case, our reflection should be like that. No, I used green for the leaving, so it would look more like that. These don't, well, it's still true that the x and the y components will flip in magnitude. The signs will not flip. They will actually stay the same. So we're going to kind of ignore that for now. I will see if I can come up with a nice, quick, easy way to fix that. But for the most part, it's not going to be a big deal. It's just every once in a while, it might get a lucky hit on the corner and then behave oddly. In this case, it would actually, rather than coming out there, it would come out over there instead. So that is the situation. We're going to take our two components. We're going to assign them to the other one, and then we are going to flip the sign from what it was originally. That's going to be how we handle this corner reflection. So let's go and take care of that. It's not going to be too bad to do because the math library already has something that makes this pretty easy to implement. So, last condition. If it's not one of those conditions, it means that we're hitting a corner. And if we hit a corner, we're going to switch the magnitudes of our velocities and then also flip the signs from whatever they were originally. In order to make this work, though, we need to come up with a couple of temporary variables that will hold on to the new velocities while we're computing using the old velocity values. If we did not do this, then it would cause an error in the second step of computing. And so what we're going to do is going to do math dot, I gotta go take a look at it quickly again. Mr. Clark's cheating, going and looking at his old code in order to remember how to do stuff. Copy sign. Copy sign. So this is actually a pretty new math function. It takes in two arguments. So it's going to return a number. It always returns a number. It's usually a floating point number. And the first argument is going to be the magnitude that this number has. And the second argument is going to give what sign it is. So we want the velocity of x to have the magnitude of the y velocity. So self.vel y. And we want it to have the opposite sign of what it came in to the corner with. So we're going to do negative self.vel x. It's not going to take the magnitude of this thing. It's just going to assign whatever this sign of this number is. And that's going to be what number this sign this takes on. It's going to have this magnitude and whatever the sign this is. We're going to do the same thing in the y direction. So math dot copy sign. This time we're going to, the y velocity is going to have the same magnitude as the old x velocity. If we updated the x velocity right here, this is going to be where the error would occur. Is because we would not be using the old x velocity, we'd be using the new one that we just calculated. So that's why I'm doing it this way. So that we finish all of our calculations with the old values, then we'll update our old new values. And this will be negative self.vel y, just like that. And then finally we can assign the values back. So self.valx is going to equal vx, and self.val_y. Actually, these are balls, sorry. I did this last time as well. Self.ball val_y equals vx equals vy. And same thing here. Ball, 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 and ball. Because the game object doesn't have a velocity, only the ball does. Alright. So, that is our bounce function. In the first case, ball is bouncing off the top or bottom. In the second case, it's bouncing off of one of the sides. And in the third case, it's bouncing off of a corner. But this one can behave a little bit oddly depending on if it comes in at a weird angle. Won't happen very often, but it'll happen. And so, what we can do is now we are prepared to actually get this thing to work and have it bounce off of things. So let's get the paddle to work first. So what we're going to need to do is we're going to need to check during our update function, is the ball hitting the paddle? And there is a very nice way to do this using Pygame, and that's using all of those rectangles objects that we created for each one of our objects. And how it works is, once again, going to see my code so I can make sure I write this properly. There it is. So we're going to ask if the self.ball.rectangle object, so that is the collision box of the ball object, and we're going to ask, is it colliding with another rectangle object? Collide rect. So this is a built-in Pygame method, and it's going to return true or false. Are these two colliding? And what we want to do is ask if it's colliding with the paddle rectangle. And if it is, then we're going to call our bounce function. Self.bounce the ball off of our paddle. That's it. That's all there is to it. So this is going to be true or false. Is our ball rectangle colliding with our paddle rectangle, our collision boxes? Let's run this thing, and we should now be able to bounce our ball off of our paddle. None of the bricks work, but oh, we got an error. What did it say? No, game object has no self.bounce. What did I call it? Oh, I did not use capital letter. Alright. Bounce. Fix it. Try it again. Alright, collide. Oh, look at that. Look at that. It's bouncing. Oh, that kind of weirdness can still happen. I've noticed that sometimes it is possible for the ball to get stuck in our paddle. The reason why it does that is what happens if it collides, but the next frame it's still in the ball, and now it's trying to collide from the inside, trying to get out. So that doesn't work super well. We're going to do something to fix that. The best way to do that would be to actually go and adjust the ball's position every time it collided with something and put it in its true position. Kind of like how we did with the bouncing off of the sides. Just to remind you guys how we did that. Here. So we set our x and the y velocity, but if we collided with something, we fix its x and y position so it's where it should have been when it collided. We're not going to do that when it's bouncing off of things because the mathematics behind that gets really complicated, and I don't want to lose you guys for, you know, something that's a small fix. Instead, what we're going to do later on is we're going to have it so that the ball and the paddle cannot collide in a short amount of time after it's already ran into each other. So it's going to be like 10th of a second or so. We'll make it so that they can't collide. The ball can then kind of travel freely. But the next time it bounces down, enough time will expire that it will be allowed to bounce off of the paddle again. So, not an ideal way to do it, but it is kind of the easiest way to do it. And it doesn't lose too much performance. Yeah, so that works. And now we are only a couple lines away from getting it so that our bricks will also work and they will disappear after we hit them. So up in our update function, we're also going to check whether or not the ball has hit any of our bricks. Exactly the same way. So we're going to do for brick in self.bricks, because we have this list of all of our bricks that we're using for drawing. We created them there. We draw them there. We're going to do the same thing here. But now we're going to check to see whether or not the ball collided with any of the bricks. So if self.ball.theRectangle collide rectangle with brick.rectangle. So has the ball's collision rectangle collided with the brick's collision rectangle? If it has, then we're going to bounce off of that brick. So self.bounce, bounce the ball off of the brick, please. Not the burk, the brick. And, well, that's all fine and good, but we also want that brick to disappear. Nice thing about it is all we have to do is remove it from the list and it'll be gone. So all we're going to do is we're going to do self.bricks.remove brick. Just like that. Remember, this is not a Pygame function. This is actually just a list function. We're saying from this list, remove the current brick. And finally, we can put in a break in order to speed things up a little bit, because once we've collided with a brick, we know that we're not going to collide with any other bricks in that particular frame. So we can stop searching. And that's it. We should now have a basic working game. So let's try running this. Make sure it works, and look at that. Look at that. We got BrickOut working more or less. Bricks are disappearing like they're supposed to. And everything is colliding basically how we expect. We'll need to make it so that it doesn't bounce into the paddle anymore. But, yeah. We now have a working game. So now it's about polishing, getting the top bar to work, maybe adding some additional elements. If you guys noticed on the original version that I showed you, the paddle movement is not so jerky. It has a little bit of a slide to it. And also the ball doesn't move at a constant velocity either. It can speed up or slow down depending on how it hits the paddle. But yeah, that is everything I wanted to show you. So next time we will fix it so that it doesn't get stuck inside the paddle as easily. It can still do it, but it won't be as easy for it to occur. And then I think we'll get that title bar done as well. After that, I want to show you guys how to put in sprites, which are just, pictures. How do you add picture elements to a game? So I'm thinking we'll make the ball into some sort of sprite. And as well as how can we add sounds, because, well, some of the suggestions I gave you for your final project involved using sounds, such as the MP3 player. So we'll take a look at those as well, probably next week. Anyways, that's all I wanted to show you. And so have a good one, and I will see you next time. Adios!